Hey, welcome back. I'm Junshan, and we are back on working with our prototype. I was doing a little bit of rewriting history and retagging videos and going back to when we started working on the prototype and renaming them to be a little bit more accurate and not mislead that and not be misleading because we're not working on the Chrono4 library. We're just using it these days. So this is already the sixth stream about the prototype. So let's carry on. Before I broke for lunch earlier, I was happy because we got the receiving part of the events wired. There's still some things missing because we are we need to take care of serialization and deserialization, but that gives me confidence that we're starting to get a little bit of a handle on how this kind of the integration of the FRP event framework with the SDOM library works, at least on one end, and that gives me a bit more confidence in trying to do it in the other direction, which is something we've been struggling with for a couple of streams. So at least before getting back to that to being stuck again, we made a little bit of progress. And actually, you know what? In the spirit of how would I say this? Rewarding ourselves for our progress, or at least following our progress. We can write that we have deal with the receiving end of events going to SDOM, and we can check that. Okay. We've tried to do this, but it turned out to be not really important. Running the tree example, maybe we'll do this, connecting this DOM event API to the FFI. So that, I guess, is part of what we've done. We just need to do the other bit. And we also need to deal with serialization. You know what? Let's do a little bit of kind of commit style and not so serialization, and then we'll need to do that socket conversion, but we are back into trying to get this sort of the state aspect of the sending end of the events to work. And so let me voice the problem again, just to sort of align. And so what we want is for a keyboard event to bubble up to the parent, which we could call root. It's really the root component here. And I think that makes more sense. So the editor is wrapped in a root component, which is really only there to receive the events in the style. There's two styles. One style where the component can update its own state directly, and that's with the write of this. Let's see. Do we have something? Yeah. The either right in an element, I suppose, is an example of what we're doing. So we have handlers here, array of handler, and one of our handlers is a key up, and it can return either can return an either of a channel or a state change function. Which is for us log to log. And here we, instead of doing a state change function, we're actually using a channel to bubble this write action through the channel, the action channel, which is part of our type. for an SDOM component. Let me show you this. Yeah, channel is the first type parameter for SDOM. And so we have an action channel, and then in the parent component, we interpret these actions into events of state modifications. And in theory, or actually in practice, this allows us to do both sort of side effectful things, like for instance, this interval 1000, which actually is firing the event every second, as well as state changing things, but pure state changing things that take a log and transform it into a new log. And in our case, by appending the operation to the log. So this works. This is not exactly what we want to do though, because what we want to do is we want to, instead of having an effect that repeats our action, we want to send, we want to use our send import FFI function to send the operation over the wire to all of the clients that would be connected to us. That's the idea with this collaborative text editing, right? So, but the problem we've been encountering, and the one I've been, publicly here on stream bumping my head pretty hard on, without necessarily making much progress, except following tangents and what we did in the stream today earlier, which was to actually try and look at it from the receiving perspective instead of the sending perspective, to kind of make a little bit of progress, which worked. We made the progress, but now we're back on trying to send something. And our problem is that we'd like to send an op with we're sending an array of ops, but we can send a singleton op here. And the problem is I need the log in order to build the op. That's just how it is with our Purescript chronofold API right now. There's some states involved, meaning we need to know the state of the current log in order to build an operation that takes into account where this operation is added into the log, and that needs to be shipped over the network. And so we're a little bit in that bind, is that we like to have ops. Sorry. We like to have ops to send, but we need to build them with the event that is accessible right here, but also with the log, but it's not accessible here. The log is only accessible in this function lambda here. And so when we were doing this on the receiving end, we were passing a callback which was receiving ops, and then because we had then ops in scope, we could append these ops to our log. And that's not the problem. We can do something exactly similar here. We could do oh no, we can't. Right, we can't, because we need the log. So yeah, we're stuck, and I don't know how to get unstuck here. Still not. And we tried a few things. We tried to maybe make the log available by passing it down to the context, but that doesn't work, because context would be available here in the handler. But then we're kind of stuck in how do we then pass the log? How do we pass the log back down to the editor? And when I try to get some inspiration from the array code, and I think that's why actually I had the run the tree example in SDOM, then I was stuck with the array example because it's implemented at a very low level. But and I can show this because it's right here. It's trying to do things. Basically, it does DOM mutation, and it needs to unwrap the SDOM. So it's very internal way to deal with that to try and make it efficient. but that meant that I couldn't read that code properly. However, there was an example, the tree example, that passed, that did something similar but didn't use the internal APIs to pass down a state through the context. So right now we kind of stopped trying to do that, but maybe it's worth trying again, because if we can pass the context, then we can build the op here, because we'll have the log available to us. So let's take a quick look, because maybe that will be you know, a little diversion from the fact that I still can't think about how to make those types aligned properly. And so maybe we'll expand our knowledge of the library by doing that. So let's look at tree, source, main. And so node is the children and tree is the parent, and the parent takes a node plus some state modification function for each node, and then creates a component which is a tree. And so what I was interested in looking at here is, how does the parent component pass down this context to the children node? Because then that context can be used as the first argument of a handler. This is not a handler, but here context is also passed. And then we can use that to simply pass the log and build our operation here instead of trying to build it here. So that's to be honest, now that I'm saying this, I'm like, it will be okay, but it'll be a little bit asymmetric, I find, even though this is also a little bit asymmetric because we're doing this outside of the component, but at least it's using the same sort of the same event-based paradigm, whereas here we'd be using some extra craft to work things around. But maybe we want to work that around, and then at least we'll have lowered the pressure to find a solution for this, because we have an alternate solution. So let's see. How do you, as a parent tree, pass down this tree context to a children node? Let's see. Oh, there's some laziness here, which is interesting. Tree channel is not what we are interested in, but maybe step context, because step context is passed to map context here via a lens, which wraps L, which is the leaf. So that's apparently the way that context is being passed down, and it makes sense. That's what map context does. And let's try and look at the signature. Sorry for that. Wow, that's loud. Yeah, I think I did a few things wrong. I need to change the volume of my desktop sound, and I need to launch back the music, and things should be nice. Okay, so map context takes a function. I think that has a contravariant feel to it, because it takes a function from the resulting context prime type, or I don't know if calling it resulting is what makes more sense. In our case, we pass to map context, we pass our L, so the leaf, So we map, this is the leaf. So we pass the leaf and a way to transform the parent context to the leaf context. So step context should be something that takes the parent context, tree context, blah. And let's check that. Well, I actually can't see that's the case. But there's, right. There's a way in which it does some smart things with to keep the resulting parent context polymorphic. So it is a function from the parent context to the child context. In which the parameter of the children context is polymorphic, as well as the context parameter of the parent. And it maps contexts of that. And so that's parent to child. And when it receives a parent of type root, then it passes the parent, the index and the parent down to the child component. So tree context is has two constructor, root and tree context. And tree context has the int, which is the index of the leaf, and the parent context. Parent context. And that's the index. So the question is, where is this index coming from? And so that's where we were stuck the other time. We were doing like a similar map context thing, but then we needed to get a log, a hand on a log in order to pass it back, to pass it down. But we had a log in the input outputs, but I didn't know how to put it in the context. And so it was similar to escaping to getting a handle on a log in order to send the op. Kind of back into like, how the hell do you get a log out from inside the component to inside a context? So can we here the difference is that we're passing an index, not passing the whole wrapper type. But how do we even do that here? Because the natural segue is that, okay, fine, we have the function that maps the parent context to the children context, but how does that parent context get set? So build tree for build a tree. That's so interesting. There's this rendering of the context as opposed to rendering of the state going on, which goes in our direction, which is that means that somehow context, well, in the case of this component here, that context is rendered at the node level. Let's we're going to be about to able to tick that box because I want to and we have played with this and I have did some side reading on applicative effect style. So let's run the example. It should be easy now that we have checked out Right, so that's going to be in experiments and Purescript that's done, yeah. And then we need to see the example and cd tree here. Right, what's the makefile say? Well, we don't have access to make here. That's strange. I think that's because our path is not set up right. Oh no, it is set up right. We do have. So we don't have make here? Yes, please do. We don't have make here. Okay, well. Right. Because it's trying to, but we need to convert that to Spago. And maybe I can. Spago build source main. No. Let's see. I think I can give it. Well, I don't need to give it the source path. I think I need to give it the module. Maybe I do need to give it the source path. And then I think I need to give it the minus P. Let's see how that works. Examples, tree, source main. Okay. Seems to work. Or not, okay. Spago install profunctor lenses. Debug trace, Spago install. Debug. And then maybe we can parcel depending on where it's expecting the index file to be. I think let's see if we can go back down into tree and try this. Oh, it's because output is now a few modules back. Okay. And then we can, well, we don't even need to pass out, in fact. We should be able to just Maybe it's better to do this parcel. It might clash with our other, so let's quit that. And HTML index.html. Right. Right, we won't even have that here. We need to go back down into Purescript. Oh no, into the. Oh no, yeah, into browser kernel fold and the node module for parcel to be there, I believe. Yeah. All right. So that's the build tree. So the node, that's the button that says whether it's expanded or not, and then has the text minus or plus, and then the text is the rendering of the context, which recurses, starts from the root and then recurses down. Oh yeah, no, actually, so starts from the leaf and then prepends the parent stuff until it gets to the root and there's nothing more to display. So here in this tree, we have two roots, we have two leaves, 0, so it's a binary tree, right? And yeah, it recurses 4 times. And it's oh right, and this is the index that's being displayed here. Yeah. Can I do this? That's not going to rebuild because of how I built stuff here, but yeah, let's not worry about this. So this parent L is a leaf. And so when we click, this boolean gets shifted, and that's whether it's expanded or not. Because we get past build tree 4, we'll build this binary tree of depth 4. But then the model, the tree model, how does that get initialized? Ah, here. Because what we are appending is app, and that has a tree of boolean there. And the tree of boolean actually get past this build tree 4, but I don't see how that's a true boolean. Build tree, I don't know, it is supposed to be, oh yeah, tree false, got it. Okay, so that's false in all of the branches. It's actually not exactly binary tree, it's a leafy binary tree. or branchy binary tree that which carries some data in each branch. So it starts with everyone false. That's right. Yeah. And you know what? I think I wanted to compile because I want to play with it a little bit. Purescript is done, and we rerun. So there was, where is it? Spago build -p and example tree source main. And we should actually watch this. Yeah. And so if I say top of the tree, or if I say yeah, all leaves except all branches instead the leaves, except the leaves are open. Unfortunately, that doesn't work in this way. So I think it will work if I do //. Oh well, yeah. No, if I say that this var main equals require / and / output / main just / main and then main. Okay, yeah, one more dot. Oh yeah. So this works, and indeed the leaves are still are closed, but there's nothing underneath. Okay, and then I wanted to see whether I could add a branch to that tree without breaking everything. And then if I can, and if I can close it too, right? That's pretty cool. But yeah, it doesn't teach us much really. So the question is, this step function, the index, how does it get passed? Is it to the lens? We pass L twice here. We pass it with the map context. I see. I think that this is hidden, or this has a class name collapsed. So this is what controls the visibility of what's below. So if we inspect, and we see we have a span underneath that's collapsed, and if we remove that, then it shows it. So in one case, this is basically used to display this well, both the button and the context. So let's look at this. Map context root, a lens prime of L. So we have our L is this node, and it has these things in it. And we then through the lens, we transform the tree context that we have at the bottom to a tuple or is it the reverse? I think we transform the tree. Yeah, we transform the tree, the parent to the children. And so we transform tree model into tree context. Tree context being oh, hold on. This lens, I'm looking at the context, but that's not right. It's the model. The lens changes the tree model to model. Right, the bottom. Oh yeah, to the Boolean. So tree model is tree A, and A is the Boolean, and then B's is the branches, and it turns it into, I think maybe I need to understand lens prime here. What's the type of lens prime? I think my ID is not working anymore. Don't know why. Let's see if we can restart it. Yeah, no, I think, oh yeah, good. So lens prime, yeah, okay, yeah. It's, oh yeah, it's that encoding of lenses where it takes the state and then returns the underlying value, and then that's the getter. So that's the, no, that's the getter. So if we get a tree LFBS, then we get an LF in it, which is exactly what we want. We want to get the Boolean, or the A, which is a Boolean, out of the tree A. And then if we were to try and set it, then it would use the second part of the tuple. But let's not care about setting it. And then we also change the context from context to tree context. So at that point, we're already passing down state. So if we were to, for instance, well, I want to do this, but I think it's just going to delete. We're going to see, yeah, only the very top. So that's not a good example for seeing how state is being passed. So is it through this map context root then that that we're able to pass down the context? So we well, with root, right, but you need to remember that that context thing is contravariant. So it's something like it takes a context and then makes a tree context out of it. And so if we have a context, and if we put root in front, then we get a tree context, a valid tree context. And so that takes care of, so that's an interesting pass through. I think, yeah, right, that's the equivalent of that either void. The either void, and with the interpret channel absurd and the trick of basically defining an either where you keep sort of this guy polymorphic by just creating a value that's the right. A right, for instance, true will be a for either, a for all C either C boolean. And with that trick, we can unconstrain or let C be polymorphic in an either. And this, I think, is the dual trick with a, oh, hold on, this is a sum as well. So maybe it's exactly the same trick. I don't know, it seems like there's a dual thing, but I'm not sure anymore. It's like by passing the root. Because when I was trying this trick, I couldn't find out what to map context with. And actually, I think I have the example of that. Yeah, I was trying to pass underscore like a lambda to unit, but that didn't work. And I was like, I can't build a log. I don't have a log on hand. But maybe it's because my top level type, which wouldn't have been units in that case. I think it was something like, well, it was a record, but maybe it shouldn't have been a record. It should have been a sum type. So not a product type, but a sum type. And then I could have just went left. So I think I'm going to try that again. By saying, instead of unit here, I mean, we keep unit here. We want to pass something down to context. So we say something like root context. And we say that type root or data root is either well, root context or something else that we want, which is maybe log, which then will have the log inside somehow. We don't know how we're going to pass that, but that would be the ideal. Right, something like that. Then we do well, then in that case we receive the ops from below. So we don't need to do the same trick. But I think we're going to be stuck in the same place that we don't know when to send them. Receiving. Okay, hold on. Let me finish the thought with regards to doing, what was it? Root here. And that means that we have contexts, we have yeah, the question is, can we have a log here? And in which case we're able to muster a log here, and we can, at least we can build our we can build our up, and so now we will have ops here. So maybe before I try and do const things, which might not mean much here, try this and get that to okay. Yeah, I think it's fine to make it parameterized. And then what? Array up with event. Yeah, that's because we didn't get to change the type of write. And then we need to also add a type parameter here. Okay. Okay, so we're top level is tree, and below is tree context. Oh, right. Okay, so the other way around. And so here we get roots, and we need to do something different depending on what we get. Let's first see whether we can get things to type check. Right, we need to call this root now. Oh, we already have a root imported from Chronofold. Top. How come this didn't cause a problem earlier? Okay, so that does compile, but we don't know whether we can extract what we need of the leaf. So let's look at what the example does here. If we're leaf, well, we don't care about this context, but we use the context here in render context. Yeah, and so we pattern match depending on what we have. Okay, so let's do that. Let's case root off. And if we have a root context, then we don't really do anything. So we can maybe do write identity. But if we get a log, where is it? Yeah, a log context. We don't care about the context here. Then we have a log, and we can do our deed. still compiles. Okay, well, I'm happy that, I don't know whether that's going to solve our problem, but I'm happy that I got this pattern right. Because we still have that problem. We don't know how to send the ops. But it means at least that we're able to pass down the log to the leaf. And let's see what that gives us. Could be that we're stuck because of this code, which we can just do this for now. No, so what goes on now? Well, it could be that we always in this case. So how would we know that? We could spy on the root. And we get root blah. And we get still root. So yeah, so we are stuck on the root, we never get the log. So why and how is this solved in tree? So in tree, we must get tree context sometimes. And how does that get passed? Meaning this other part of things. So in this case, we always wrap it with root. But do we do something different? Yes, we do something different. That's when we do map context of this thing. Okay. So let's have something similar to that. Instead of mapping root, let's map this step context. And it's going to be something from here we have a record, here we have a product type. I'm a bit lost here. Oh, is that because that's what's passed to tree context? No. Where is this data structure coming from? I guess it's maybe just a temporary thing that just only exists in the... Oh, so it's either that... No, it looks like maybe that's where it is. Okay, well, let's try it. And so now root of index, root of log and parent would be a root of log and yeah, right. So that's an interesting transformation right there. And then root of log and context would just be root of log and then recurse on the context. Root? I don't know, this is all very strange. Right. I think this is root context here. and here is log. And then here is log. Oh, yeah, in one of these I need to go, I think, like this, or even maybe, right, right, oopsie, pattern match like this, and then like this. And right, and then I've got this problem that where is this lock parent thing going on? And so let's see. Index, where else is index present in this code? It's only present in these 5 places. And the step context only present here. It is wrapped in a lens. But that shouldn't affect the context. However, maybe go... Oh, there's a recursion there, which we don't have in our case. Even then, I don't see... We use the index here. And we don't constrain that context here. So in theory, this context could be this weird thing. And then, but then we do call tree here. Oh, maybe I need to be careful about the scope of the type variable, but I am. It's not the same here and here. Is it that the with async is going to change the type of this function, for instance? No. Okay, change the context. Could not match type root with type context. Channel. The context one is the type, I think, of the parent. What are we missing here? Context, tree context, context. No, that's for channel. Context is our problem. Okay, maybe parent is called somewhere. Also not. So this type is a bit of a mystery. In map context, it's supposed to be the type of the resulting context. So the parent context. So L has the tree context, but then as soon as we're here, and we should be able to check this with type annotation, we should have the type of the record thing. Yeah. Context has this index parent thing. So interpret channel shouldn't modify anything with regards to that. Go supposedly takes a tree context, but we don't have a tree context. We have, oh no, we do. We have a tree context of an index and a parent this time. So is that it? Is that the fact that we need to say that actually this is a root context as well? I think this will make a problem with our attachments at the, and we won't be able to attach properly, no? Exactly the same error message. Let's double check the structure of this type with tree context here. Maybe it would be easier to parse if I call this lock context. But it's the same thing here. It's very obvious. Sometimes, as I said before, names help a lot, because I might have gotten this wrong. It's not impossible at all. Yeah, for instance, this, are we really emitting two log contexts there? We are. So it's, and then the root inside. So no, that's correct. But magically, what? No, I must have made an error somewhere else. Yeah, okay, yeah, of course. And here, and we're probably back exactly the same point. Yeah, we are. And calling this context doesn't change anything. Same error, yeah. So, I mean, I understand that this is a recursive data structure, that's not an issue, but somewhere at the boundary, we get back to a context and things are happy. So when does this happen? When does this... Right, so that's not the handler, it's the array of children components. Oh boy, this is it. It's the array combinator. There's this like interaction between the array component combinator and that int parent business. So in fact, even though I thought that trees would be an example that would allow us to figure out how to deal with that index, in fact, it's depending on the underlying implementation of the way that array does it. Huh. Tricky trickster. Yeah. Okay, well, we're past my time for this stream. I'm supposed to be jumping into the streaming tool stream, so I'm gonna do that right now. Thanks for following, and we will get down to this. We will solve this issue at some point, I'm sure. I'm probably gonna stream tomorrow as well to try and get this done. So thanks a lot for watching, and see you soon.